Hello and welcome back. In this video we'll start section 5.4, in this video we'll start section 5.4, which is on systems of nonlinear equations. And when we think of nonlinear equations, this means that we have terms that involve things that aren't just x times a number. So for instance here we have an x squared term, and because this isn't just x times some number or a number by itself, this is nonlinear. And then over here, for instance, we have not only an x squared, but a y squared and another x squared. So these are nonlinear equations. This equation here, in this, let me draw a box around this. This equation happens to be a linear equation. All of the terms are raised just to the first power. We've got an x and we've got a y. But because we're considering systems of equations meaning multiple equations at once, since the top one is nonlinear, the whole system is called a nonlinear equation. And the methods that we would use to solve nonlinear equations, as in finding the solutions to these, include substitution and addition. And by solution, this is just like before. So for instance, with this equation here, if we tried to plug in 0, 3, we would find that this is a solution. Why? If I plugged 0 in for x and 3 in for y into the top equation, I would get that 3 is equal to 0 squared plus 3, which that's true because 3 is equal to 0 plus 3. And the bottom equation, I would have 0 squared plus 3 squared is equal to 9. And that is also true, since 0 squared is 0 and 3 squared is 9. So this is a solution to this system of equations. So everything is just like we've been seeing before. We can check to see if something is a solution by just plugging it in. And our goal is to just try to find these solutions. So here we have two equations. This is a nonlinear system of equations because we have an x squared term. So let's use substitution here. And the way that we use substitution is we solve for one variable and plug it back into the other equation. So here, when I look at this bottom equation, I can solve for y pretty easily. So let's start with this equation and let's solve for y. Maybe I will move the 4x to the other side. So I'll subtract 4x from both sides. So we'll get minus y is equal to negative 1 minus 4x. And I have a minus sign there, so I'll multiply everything by negative 1. Negative 1 times negative y is just y. Negative 1 times negative 1 is 1. Negative 1 times negative 4x, well, that's positive 4x. So now I know that y is equal to 1 plus 4x. And I can plug this back into my equation. So I'm going to substitute. I know that y is equal to this thing, so I'm going to substitute it into this equation up here. So next we get to take our top equation. So if I call this equation 1, I'm going to plug this back in. So I've got x squared is equal to y, which I know is 1 plus 4x minus 1. You see that we have a plus 1 plus 4x minus 1, so the plus 1 and 4, and that cancel out. We are nearly there, so let's move the 4x to the other side. I'm going to subtract 4x from both sides. So we'll get x squared minus 4x is equal to 0. And this I can factor. I can pull an x out of both of these. If I pull an x out of this first one, x times x is x squared. Pull an x out of the second one, we get minus 4, everything's equal to 0. And if I have two numbers that multiply together to get 0, one of them has to get 0. So one of my solutions is going to be 0, or x is equal to positive 4. If I plug a positive 4 into here, I get 0. If I plug a 0 into x, I get 0. So I know that x is either 0 or 4. Those are my two options. And if I come back up here, I can see, let's use this top one here. I've got x squared is equal to y minus 1. And I know what x is, which means that I can solve for y. So again, using this top equation, we've got x squared is equal to y minus 1. So let's plug in 0 first. So if I plug 0 into x, I get 0 squared is equal to y minus 1. Well, 0 squared is just 0. And if I add 1 to both sides, I get 1 is equal to y. Perfect. So when x is 0, y has to be 1. Let's plug in 4 for x, which is our other solution. So if I plug 4 in for x, I get 4 squared is equal to y minus 1. I know that 4 squared is 16, and then I'll add 1 to both sides. So y has to be 17. And what we can do is we can actually check the other equation as well. So we did all this using the first equation. Let's check the other one. If x is 0 and y is 1, let's see if this works. So let's check. If I plug in x is 0 and y is 1 into this equation, I get 4 times 0 minus 1. 4 times 0 is just 0. Minus 1 is negative 1. Oh, that works. The next one, if I take 4 times now the second solution for x minus what I know y is, and I get 4 times 4 is 16 minus 17. Oh, that's also equal to negative 1, which it should be. So our two solutions, when x is 0, so let me write it like this. So our solutions, when x is 0, we knew that y had to be 1. And when x was 4, we knew that y had to be 17. And those are our two solutions. Let's look at this guy. So again, so this bottom equation looks a little bit more complicated. This top one is not too bad. And if I want to use substitution, I can solve for one of these pretty easily. And in fact, if I solve for x here, it'll be x will be equal to negative 2y after I subtract 2y from both sides. Perfect. So now I know that x is just equal to 2y, and I can substitute it in to the second equation. So if x is equal to negative 2y, I can plug that in, and I get negative 2y minus 1 squared plus y minus 1 squared is equal to 5. And all that's left is to solve this. So let's FOIL everything out and simplify. So here, if we FOIL, we'll have negative 2y times negative 2y. That will be 4y squared. If I take the first and the last, that will be plus 2y. Again, the first times the last again, so that will be plus 2y. And then negative 1 times negative 1 is plus 1. Moving on, let's FOIL this. Y times y is y squared. So that's the first. The outer terms, y times negative 1. The inner terms, y times negative 1. And then 1 times 1, negative 1 times negative 1 is plus 1. So let's consolidate a few things. I have a couple of y squared terms. When I add these together, I will get 5y squared. I have some y terms. I've got 2y, another 2y, minus y, and minus y. So 2 and 2, that's 4, minus 1 is 3, minus another 1 is 2. And then lastly, I've got a 1 and a 1. So it adds up to 2 with a 5 on the other side, and I'll subtract 5 to get minus 3. And we can look at this, and maybe we don't see if it will factor very easily, very nicely. So let's use our quadratic formula. So just to remind ourselves what the quadratic formula is, in this case this will be y will be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a bit of a mouthful, but in this case we can plug in our values. A is 5, b is 2, and c is negative 3. So this will be equal to negative 2 plus or minus the square root of 2 squared minus 4 times a, which is 5, times c, which is negative 3. Oops. All over 2 times a, and a is 5. So let's simplify. We've got minus 2 plus or minus the square root of, so that's 4. 4 times 5 is 20, times 3 is 60, and we are subtracting that. It's a negative and a negative, so those cancel out. So that's 60. And then 2 times 5, well, that's 10 on the bottom. 4 and 60, that's 64. And the square root of 64 is 8. So then lastly, if I take negative 2 plus 8 over 10 and negative 2 minus 8 over 10. So one solution is going to be negative 2 plus 8 over 10, and the other solution is going to be negative 2 minus 8 over 10. Both of these simplify. Negative 2 plus 8, that is negative 6. Sorry, positive 6. And then this one is negative 2 minus 8. Well, that's negative 10 divided by 10, and both of these simplify. 6 over 9, 6 over 10 is 3/5, and in this one, we've got negative 10 over 10, which is just negative 1. So we know that y is either 3/5 or negative 1. That's a lot of work for one variable, but we have two variables. Luckily, this top equation is pretty straightforward. X is equal to x plus 2y is equal to 0. So let's just use that. Let me write that down. X plus 2y is equal to 0. So let's plug in these values and see what x is. So for when y is equal to 3/5, we have x plus 2 times 3/5 is equal to 0. 2 times 3/5, that is 6/5. And if I subtract 6/5 from both sides, we get that x is equal to negative 6 over 5. Over here, when y is equal to negative 1, I'll have x plus 2 times negative 1 is equal to 0. So x minus 2 is equal to 0, so x is equal to 2. And then voila, we have our two solutions. In this case, there happen to be two solutions. We have x is negative 6/5. When y is 3/5. And another solution, when x is 2, y is negative 1. And this, I'll just draw a picture of what's going on here really quickly. Both of these we can graph, in fact. So for this top line, we nearly solved it for y here. So let me just mention that that top line is in fact just a straight line, and it is y is equal to negative 1/2 x. So this line will look like this guy. The second one, x minus 1 squared plus x minus 1 squared is equal to 5. This is the equation of a formula, this is the equation of a circle, which we saw before. Its center is at 1, 1, and its radius is going to be the square root of 5. Remember that the radius on this side so r squared will be equal to 5. So the radius is equal to the square root of 5. So the center of that circle is going to be up here, and the radius is 5. So as we draw the circle, we get something that looks roughly like this. I'm not doing this very precisely, but we can see that, yeah, we should have two solutions, and those two solutions are right here. Negative 6/5, 3/5, and 2, negative 1. So our picture matches what we would think. the solutions to a system of equations being where those graphs intersect.